Hello everyone, welcome to math class. Our topic today is going to be on inequality. Okay, so what we are going to focus on this class today is linear inequality of one variable. Linear inequality of one variable. In our previous classes, we have studied linear equality of one variable. But this time around, we have linear inequality of one variable. When we say an inequality, we are talking about sign of less than equals to, greater than equal to, less than, greater than. These are the four signs that we use in inequality. Okay, so the use of this sign instead of equality sign is what makes it different from linear equality of one variable and linear inequality of what? One variable. Okay, so we are going to solve example, but the question now is that how do we solve linear inequality of one variable? The same way we solve linear equality or linear equation of one variable. There is no different way of solving the two. The only difference is that whenever we divide by a negative sign, the inequality sign will change sign. Okay? What it means is that if we divide by a negative sign or if we multiply by a negative sign, if the inequality was in this form, it is going to change to this form. If the inequality was like this, it's going to inequality was like this, is going to change like this. If the inequality was like this, it's going to change like this. So whenever we divide or multiply by a negative number, the inequality will change side. If it was facing this way, it will turn and face this way. If it was facing this way, it will turn and face this way. That is the only difference between linear equality of one variable and linear equation of one variable. So we are going to solve some examples so that you can be able to see these differences. Number one, 2x plus 1 less than 5. Meanwhile, some people are always confused which one is less and which one is greater than. It is not about where it's facing, okay, because a sign that is less can also be reversed or read as greater than, depending on where you are reading from. That's what makes it less than or greater than. Let me show you an example. If I have x less than 2, we say that x is less than 2. But you know that in mathematics, there is no rule of where to read from. In a mathematical equation, there is no rule that you must read from here to here or you must read from here to here. In mathematics, we can call our equation either from any side. It's either you can call it from the left-hand side to the right-hand side or from the right-hand side to the what? Left-hand side. So in this case, somebody else can say that 2 is greater than x. And they are the same. Okay, the most important thing is for you to know which side is greater, which side is what? Less than. Look at this. You can see that the space between these two lines is bigger here than as it's coming back here. So the more it's come back, it reduces. So it simply means that whatever is on this side of this inequality is bigger than whatever that is on this side of the inequality. Now let us solve for the solution of this problem. Like I said initially in the beginning of this video, that the inequality, we solve it exactly the same way we solve an equation. There is nothing different in the solving except when you divide by a negative sign. Now let us solve this problem. The same way I will solve if there is an equality here, that is the same way I'm going to solve this problem. So I have 2x plus 1 less than 5. Now I will take my 1 over to the right hand side. That will give me 2s less than 5 minus 1. So I will have 2s less than 4. Now I need x to be alone. So I will divide both sides by what? X by 2. So I will divide both sides by 2. When I divide both sides by 2 here, 2 here, these 2 here will cancel out these 2. I'll have s less than 2 here, 1, 2 here, 2. So less than 2. So that's the answer to that inequality. Let us take a second example. X plus 5 greater than or equal to 3x minus 2. I have a little advice I normally give to my students. I always tell them to move the x that is less to meet the x that is more. If you have here, if you look here, we have 1s here and we have 3x here. This 1s is going to move to meet the 3s because the 3s is more. There is no rule that this must be this way because you can take this 3s to meet this one. Okay? So let us take this 3s to meet this. What we are going to have, let's have our solution. What we are going to have is that this 3s will come here, x minus 3s greater than or equal to, this 5 will move over here to meet this minus 2. So I have minus 2 minus 5. This is 1x minus 3x, that will give me 2x greater than or equal to minus 2 will give me minus 7. Now I need my 2, I need my s, I need to remove minus 2, so I need to get minus 2 out of the way. So I have to divide both sides by minus 2. The same way I divided both sides here by 2, that is the same way I'm going to divide here. But remember, I said earlier that when you divide by a negative sign, the inequality sign will change face. If it was facing this way, it's going to face that way. So let us do that. Minus 2x over minus 2, it will not change to this. Minus 7 over minus 2. Minus 2 will cancel out minus 2 here. That will give us x less than or equal to, minus divided by minus will give us positive number. So I have 7 over 2. So you can see the only difference between inequality and an equation, which is equality. Anytime you have any problem of this nature, the only thing to do, solve the way you solve your linear equation by collecting all the like terms on one part of the equation. Then in inequality, when you divide by a negative sign, the inequality sign will change, will reverse. So if it was greater than, it's going to become less than. If it was less than, it's going to become greater than. So let us solve one more example before we move to graphical representation of an inequality. So we have this. What are we going to do? It is very simple. The first thing we always do is to make sure we open our bracket, collect our like terms, and make S the subject. Let's open this bracket. 3 times 3s will give us what? 9x. 3 times plus 1 will give us plus 3 minus 2x less than equal to 5 minus x. So you can see that I have an expression 9s minus 2s and minus s. So I need to bring this minus s over here. Then I have a constant here, which is plus 3. This plus 3 needs to move what? Over there. So that will give us 9x minus 2x. When this one cross over here, it becomes what? Plus s. Less than or equal to 5. Plus 3 is going to cross over there to give us minus 3. 9 minus 2x will give us 7x plus x. You have what? 8x. Less than or equal to 5 minus 3 will give us what? 2. So we now need to set our x free by dividing both sides by what? 8. So I have 8x over 8 less than or equal to 2 over 8. 8 will cancel out this 8. I'll have x less than or equal to what? 2 here, 1, 2 here, 4. So that will give us 1 over 4. So you can see how simple that is. Okay? So we are going to look at inequality that involve fraction. Let us look at graphical representation of an inequality of one variable. Now, how do we represent an inequality of one variable? It is very simple. We need to know, or we need to note that when you have less than equal to or greater than equal to, we make use of this or this. Shaded, shaded. And when we have this or this, we make use of this, this. So whichever one we are going to use depending on where we have our x. Whether we have our x here or x there, it depends, okay? So we are going to see all that in a little while now. So this is the arrow we use in representing our inequality. But remember, this is inequality of one variable. So the only way we can plot this graph is on a number line. So we call this graph a number graph. We are going to use a number line to plot the graph. So let us look at some of these examples here. If I have x less than 2, how will I represent this in a number graph? This will give me, I'll have my number graph. Of course, I have to make a reference to 0. There is 2 here, so I get my 2. This is my 2 there. Okay. Then I have greater than, which is strictly makes use of the empty circle. So I have my empty circle. X is greater than 2. Here is 2. So let's say x is greater than let's say x is greater than 2. So what I will do here is to first of all sketch my number line. So I can make reference of 0, not necessarily, but I'm making reference of 0 because this number is a little bit close to 0. Then after getting my 0, I can get my what? 2. Greater than, we make use of empty circle that is not shaded for greater than or less than. So I will put that here. Now, if you check at this point, we have all these numbers. We have 1 is here, 0 is here, of course, -1, -2, it continues like that. Then here we have, okay, let me make a little reference of that, -1, -2. Under this part, we have 3, 4, 5. Now, the question now is that from here, of course, inequality is about a region, okay, a particular set of numbers, not an exact like equality. So the question now is, which of these side is actually greater than 2? The numbers here, are they greater than 2, or the numbers here are greater than 2? Now, if you look at this set of numbers, you notice that 3, 4, 5 are greater than 2, and our s are set of numbers that are greater than 2. So what are we going to do? We put this direction here as x. So our x is a number that is greater than 2. Okay, so all numbers that are greater than 2, there is a possibility that's going to be 3 or 4 or 5, etc. Now let us look at another one. Let's say y is less than or equals to 4. How will I represent this? First thing, let us assume that y is less than 4. How are we going to represent this in a number graph? Just the same way I have done here, I first of all sketch my line. I can decide to have my 3, 4, 5, 2. So, of course, you know that number lines contain all the integers. So, from here, I will get my circle. Is shaded for less than equal to or greater than equal to. So, I have to shade that. Now, if you see y is less than 4, if you notice that this set of numbers are less than 4, so I will say that my y will be on this part. If you see that this y is facing the part that are less than 4, so that's how we can represent that particular uh, inequality in a graph. So what we are going to do next is to solve some problems in inequality which you are likely to see fractions, brackets, but inequality, not equation. So let's see how that looks like. We have these two inequalities and we want to represent them in a graph. So we are going to solve them first, then represent them in a graph. So we'll take this one as our number 1 and we'll take this one as our number 2. So the first one, I have it as 1 over 2 into 3x minus 2 less than or equal to 1 over 3 into x plus 4. So what we are going to do here is to first thing to do, remove the fraction. So that's the first thing we need to do, remove the fraction. And how do we remove the fraction? Multiply both sides by the LCM of the denominator of the fraction. So in this case, the denominator of the fraction here is 2, while the denominator of the fraction here is 3. So when you find the LCM of 2 and 3, you will have 6. So you're going to use 6 to multiply this and use 6 to multiply this. So that will give us 6 times 1 over 2 into 3s minus 2 less than or equals to 6 times 1 over 3 into x plus 4. Okay, so you can see I have used 6 here to multiply both sides of the expressions. So this will go with this and give us 3. This will go with this and give us 2. So what I have here is 3 into 3x minus 2 less than equal to 2 into x plus 4. Okay, so when you open this bracket now, you are going to have 9x minus 6 less than equal to 2x plus 8. Okay, so let's finish up on this side of the board. So you have 9x minus 6 less than equal to 2x plus 8. So you have to collect like terms. Remember, there is no difference between inequality and an equation. The only difference is that when you divide by a negative sign or when you multiply by a negative sign, the inequality sign will change. If it was 9x minus 2x, that's because when these two here cross over the inequality sign, it will change to negative, then less than equal to, I have 8 already, then this minus 6 will cross over to give me plus 6. So 9 minus 2x, 9x minus 2x will give me 7x less than equal to 14. So all I need to do is to divide both sides by 7. So that will give me 7s over 7 less than equal to 14 over 7. Okay, so with that now, we can cancel out the 7 here. So 7 here will give me 1, 7 here will give me 2. So I have x less than equal to 2. So I have gotten my answer. So the next thing I will do there now is to represent this my answer in a line graph. Okay, remember we just finished explaining line graph now, so we can be able to easily represent this in a line graph. So I'll get my number 0, 2. So s is starting from 2 is less, so and is less than equals to, so I have to shade it and point out my arrow for x. So x is the range of numbers that is less than 2. So anything less than 2 can be x. Okay, so we are going to wipe the board and solve the second problem over there. So the second question here, we have an expression and an expression here. So the first thing I will do is to put these expressions in brackets individually. Okay, so that will give us 1 plus 4x over 2 minus, this will give me 5 plus 2x over less than x minus 2 over 1. So what I have done here is to put these expressions in brackets. Then this one that is not a fraction, I make it a fraction. So that will give me what I have on the board already. So what needs to do is to find the LCM of 2, 7, and 1. LCM of 2, 7, and 1 will give me 14. So I will use 14 to multiply each of these fractions, okay? Each of these fractions. So when I get the LCM, which is 14, I will use it and multiply here. So I'll have 14 into 1 plus 4x over 2 minus 14 into 5 plus 2s over 7 less than 14 into x minus 2 over 1. Okay, so let's move to this part. So when I cancel 2 here, I'll have 1, 2 here, I'll have 7, 7 here, I'll have 1, 7 here, I'll have 2. So 1 here will go in 14 to still give me what? 14. So that will give me 7 into 1 plus 4x minus 2 into 5 plus 2x less than 14 into x minus 2. So the next thing to do is to open the bracket. Okay. So when you open the bracket, you are going to have 7 plus 28x. That's 7 times 1, 7. 7 times 4x, 28x, minus 2 times 5, minus 10, minus 2 times minus 2s, minus 4x, less than 14 times s will give me 14x, and 14 times minus 2 will give me minus 28. Okay, so the next thing now is to collect like terms all our x. Okay, all the expressions that have s in them, so I have to collect them on one part of the equation and put the other ones on the other side. So what I have here is going to give me 28x minus 4x. So this 14x is going to come over here to give me minus 14x, less than, I have minus 28 here. So this one will come over to become plus 10. Okay, so that will give me plus 10. 7 will move over to give me minus 7. Okay, so I'll take care of this, I'll take care of this. 28 minus 4, that will give me 24s. 24s minus 14s, that will give me 10x, less than 20 minus 28 plus 10 will give me minus 18. Minus 18 minus 7 will give me minus 25. Okay, so the next thing to do now is to divide through by 10 so that I can have my value. So 10x over 10 less than minus 25 over 10. 10 here will go in this, so I have x less than 5 here, 2, 5 here, 5. So that will give me minus 2, 5, sorry, minus 5 over 2. And minus 5 over 2 is the same thing with s less than minus 2.5. So whichever one, either as a fraction or as a decimal. So the next thing I'm going to do there now is to represent this thing here in in a graph. Okay, I will represent it in a graph. So that will give me, I will sketch my graph 0. So that's negative. So I have minus 2.5, and s is less. So strictly less. So empty circle. Then I'll put my, because this part is where we have numbers that are less. So from here, the numbers start reducing. From here, the number starts increasing. So I have my arrow, then my s here. Okay, so that's the how we can solve linear inequality of one variable. And